Hello class, we're going to go over section P7's homework and then we're going to do section P9. So let's go checking. You can check those answers and I'm going to work the problems on the right. So here we go. In problem 16, seeing we have fractions, this is an equation that contains fractions, I'd rather get rid of the fractions. So that means I want to multiply through by the common denominator. Well, those denominators are 5, 2, and 3, so the common denominator would be the number 30. So I'm going to multiply through the whole thing by 30. In the first term, 5 cancels into 30, leaves 6. 6 times 3x is 18x. 2 goes into 30 15 times, but I do want to remember this is minus in front here. So I will say negative 15 times that numerator, so negative 15 times x, and negative 15 times negative 3, positive 45. And then the 3 goes into 30 10 times, so 10 times this numerator is 10x and 20. And finishing the problem, this gives us 3x on the left. Plus 45 equals 10x plus 20. Subtract 3, so that gives me 7x on the right, equals 45. Subtract a 20 gives me 25 equals 7x. And this answer is not a very pretty answer, but it's 25/7. Perfectly good number. All right. Problem 20. Problem 20. It's a rational equation because we have variables in the denominator. So be reminded, we have to double check our answers to see if any answer we got would cause those denominators to be 0. So let's go solve. With fractions, we're going to multiply through by the common denominator. And it's pretty simple to see that's just going to be an x minus 2 because that's the only denominator there is. In the first term, when I multiply, the x minus 2 cancels out completely, and we're just left with 1 times 2. In this next term, the x minus 2 will cancel the one we're multiplying through by, and then it's 1 times x, or x. But the minus 2 has a 1 denominator, so nothing's going to cancel, so we'll distribute negative 2 times x minus 2, negative 2x plus 4. X minus 2x is negative x plus 4 equals 2. So negative x is negative 2 and x is 2. There's our solution, but we need to look at our denominator and see what our excluded value should be. And if I look at that denominator, x minus 2, the value that x cannot be is a 2. Uh-oh. We got to happen in 2 places. It can't be 2, but it is 2. What does that mean? That means we have to toss this one out, and my solution set is empty. Okay, I'm assuming you've done through number 32 or checked through 32, and we'll move on. Here are the next solutions, but I'm going to work these 3 problems. S equals C over 1 minus R, and you're solving for R. Here we have the variable I'm solving for is in the denominator. So essentially, I'm going to think of this as if it's proportion. I'm going to begin solving by cross multiplying. So S times the 1 minus R equals 1 times C is C. In that problem, I don't want to distribute the S because I can now get rid of it now that my parentheses are gone. Let's divide by S. So C over S, and then I need to subtract a 1. So negative R equals C over S minus 1, and then if I multiply through by negative 1, I get R equals negative C plus S plus 1. Is that what that says? Yes, it is. There you go. Okay? Number 40. All right, we're solving for R sub 1. And we look and we have variables in the denominator. We learned that to get variables out of the denominator, I'm going to multiply through by the common denominator. Every one of those denominators is different. So my common denominator is the product of all three of those. So my common denominator that I'm going to multiply by is r times r sub 1 times r sub 2. So in the first term, it cancels the r, leaving an r, that's not very pretty, let's try that again, r sub 1 times r sub 2 equals, the second term here, the r sub 1 will cancel, which will leave r times r sub 2 times that 1, which would be r times r sub 2. Plus, and in the third term, the r sub 2 cancels, leaving an r times r sub 1. Okay, now we just think, what am I solving for? We're solving for r sub 1, and we look around, and we see that r sub 1 is in two different places. So I need to pull those two terms to the same side. So r sub 1, r sub 2, minus r sub 1 equals r times r sub 2. At this point in time, my two r sub 1's are on the same side. Now I can see that they are a common factor and take them out. Factoring them out, it leaves an r sub 2 minus r, equaling what we have on the other side. Okay? And now at this point, I can divide by the parentheses, and we should be finished. R times r sub 2 divided by r sub 2 minus r. Okay? There you have it. Problem 52. Let's see. I'm going to push that. Let's get rid of that, and I'll do this. Okay, giving me a little bit more room here. 52. And now that I look at it, maybe I don't need room. Absolute value of x plus 1 plus 6 equals 2. If you're solving an absolute value problem, you want to isolate the absolute value. So here's my absolute value. The plus 6 I need to subtract and get it to the other side. So this becomes a negative 4 on the right. At this point, it says an absolute value equals a negative number. Can that ever happen? No, that never happens, so this is an inconsistent equation. It has no solution. All right, moving on. There are some more solutions, and I'll work these problems for you. Number 64, 3x squared minus 1 equals 47. If we look carefully, we notice there is no linear term here. So since there's not, that means I can just go ahead and just start solving for x squared and then solve for x. So let's isolate the x squared term. That means I add 1 to both sides. Now I'll divide by 3. Now we take the square root of both sides, but be careful, 16 has two square roots, a positive and a negative 4. Okay? Number 68. Let's see if that'll move up a little bit. There we go. Okay? Here we see we do have a linear term, a quadratic term, and a constant. We need to move everything to one side. So we're going to bring that minus 8 over, and it becomes a positive 8. And factor, if possible. Are there factors of 8 that add to be 6? Well, 4 times 2 is 8, and they add to be 6. So we got our x's in the front, signs are alike, they are both plus, and our two solutions are a negative 4 and a negative 2. Okay? Moving on. There's some more things to check, and I'll work problem number 92. Problem 92 is already set up. One side's 0. That's great. I have a trinomial, so I've got to try to factor it. I will multiply my coefficient in the front, the 3, times the 4 in the back, and ask myself, that's 12, are there factors of 12 that subtract to be 4? Factors of 12 that subtract to be 4. Well, yeah, 6 and 2. So I'm going to take this middle term, break it into 6x and 2x, bring down my constant and my lead term, and I need two signs to go right there in the middle with those two terms I just made. Looking at the signs at the top, the signs are different. The minus sign goes with the large one, so that's going to go with the 6x, and a plus goes with the 2. So now I have a problem I can factor by grouping, and the common factor in the first two is 3x, leaving x minus 2. In the second pair of terms, the common factor is a positive 2. That leaves an x minus 2. And now we know how we factor by grouping. In this case, the parentheses is the common factor, x minus 2. So we bring that out, leaving 3x plus 2. Okay, and we're solving. So if we're solving, I need to keep going and set each of these two equal to 0. The first one I can do in my head real quickly, that's a 2. Some of you might need to see the work for that one, so I'll do this one. 3x plus 2 equals 0. So 3x is negative 2, and divide by 3, negative 2/3. Okay? I started to say any questions, but I'm not there to answer them. I hope that has answered the questions you would have over these problems. And we're almost done. Here's the end of the ones you had to solve. They're 3 points apiece. You can put a grade on your paper when you get to that point. I'm going to work these two problems on the right. Number 12, this is a rational equation having variables in the denominator. I need to multiply through by the common denominator, and each one of those denominators is different. So essentially, I need to multiply by the product of all of those. Please leave them, don't distribute anything, okay? So I'm going to put the 4 and x together. 4x times x plus 3 will be what I'm going to multiply each term by, canceling out the denominator each time. So in the first one, the x cancels. I've got 4 times x plus 3 times the 1 numerator gives me 4x plus 12. Does everybody see where the 12 came from? Okay. The next term, x plus 3 is going to cancel out, which leaves a 4x. 4x times 1 is just 4x. And on the right-hand side, the 4 is going to cancel, which leaves the x term times the x plus 3 times the 1 on the right. So I've got x squared plus 3x. That particular move just made this a quadratic equation. So seeing that it's quadratic, we want to move everything, in this case, to the right. So let's be careful. There's the x squared. On the left, 4x plus 4x is 8x. I need to subtract 8x from the 3x, negative 5x. Then the minus 12, I need to get rid of it, so it's going to be minus 12 when it comes up on the right. There we go. Are there factors of 12 that subtract to be 5? No. And this particular problem, the middle term is not an even coefficient, so that means I'm going to use the quadratic formula. So x equals negative b, which would be a positive 5, plus and minus the square root of negative 5 squared minus 4 times a, which is a 1, times c, negative 12, all over 2a. 2 times 1. Looks like I need some more room, so I'm going to take this problem and move it down. Here we go. So we have 5 plus and minus 25 plus 48 all over 2. 25 and 48 is 73. Wow, that's not a pretty number. All over 2. And that looks like as far as I can go. Look to the left. Is that the answer? Sure was. There it is. Okay, you did have to use the quadratic formula on that one. Okay, and now number 116. This one is a radical equation. So we need to, first step is to isolate the radical, and that's already been done for us. Thank you. The next step is square both sides. So if I square the left, the square root of 20 minus 8x quantity squared is 20 minus 8x. And the right-hand side will be x squared. It's now turned to be quadratic, so we need to do those rules. One side needs to be 0. I'm going to make the left side 0 because the x squared term's positive on the right. Moving everything else over, positive 8x, negative 20. Are there factors of 20 that subtract to be 8? Moving that up a little bit. Yes, there are. 10 and 2. 10 minus 2 is 8. 10 times 2 is 20. All right, signs are different. The plus goes with the big number, that's the 10. Solutions. Solutions are negative 10 and positive 2. This is a radical equation. We need to check our solutions because we squared both sides, possibly giving ourselves an erroneous solution. So let's check, being very careful. Negative 8 times negative 10 is a positive 80. So 20 plus 80, because it became positive, is 100. The square root of 100 is 10. And on the right-hand side, that says x, but x was negative 10. Doesn't seem like that one's going to work. I'm thinking I'm throwing that one away, but I'm going to check the 2 before I cross it out, okay? 8 times 2 is 16. 20 minus 16 is 4. Square root of 4 is 2. On the right-hand side, what will we plug in? X was 2. Yeah, 2 works. Negative 10 does not. Okay? All right, hope you saw enough of those to fill in any questions that you had. In class, you should pause the video and pass in your homework papers with the grade on it. They're 3 points apiece. Please pass things in. Find your notes and let's get started. Math Analysis, Section P9. Linear inequalities. Graphs of inequalities and interval notation. Back in section, I don't know, I think it was 1, we talked about set builder notation, and I skipped it a little bit. We're going to put the two together today. We're going to have some set builder notation and some interval notation, so you'll kind of see them compared to one another. So we'll take care of that vocabulary here in this lesson. All right, let's begin. Do not write the sentence. Okay, don't write the sentence. Let's just talk. There are infinitely many solutions to the inequality x is greater than negative 4. Namely, all the real numbers that are greater than negative 4. Although we cannot list all those solutions, we can make a drawing on a number line that represents these solutions. Such a drawing is called the graph of the inequality. So I put a box around that inequality. Write that one on your paper. Draw a number line. And let's just remember what we know already. Okay? Reviewing how do we graph an inequality. It's a number line. I can look at any part of it I want to. I can zoom in over at 1,000,000, or I can zoom in at negative 100. Or you can zoom in at 0, which is normally what you see in the middle of the picture. But this is math analysis, so we're going to zoom in on the important points of my problem. So I'm zooming in right here, and this is going to be my -4. Okay? Now, do I know what's to the right? Yeah, a -3, a -2, a -1, anything bigger than 4. Do I know what's to the left? Yes, a -5, a -6, a -7, and all the things less than -4. We don't have to put all the little hash marks here in math analysis, okay? I know that you could make a beautiful number line. My point is, we need the critical points on here, and that's about it, okay? Other than, of course, what we're going to shade. So let's talk about which part we shade. We are looking for all the points that are greater than. Greater than is to the right. So we are going to shade this line, my number line, shade it all the way to the arrow, and please make a bold arrow there so we know which way it's going. And then the next question is, what about -4? Well, previously in the things you have done with this, you would have asked yourself, is -4 included? Looking at the symbol, you see, oops, it's not. It says just greater than, doesn't say equal, and you would have put an open circle around the -4. Okay? You're going to learn something a little new in the next page here, but that's what you know already. That is a picture of all the points that are less than -4. Okay? All right. Graphs of solutions to linear inequalities are shown on a number line by shading all the points representing numbers that are solutions. Here's something new. You need to write this down. Parentheses indicate endpoints that are not solutions. So write that whole sentence. But let me read the next one. Square brackets indicate endpoints that are solutions. Write those two sentences. That's the new information, and I'll show you what that looks like. Parentheses indicate endpoints that are not solutions. Square brackets indicate endpoints that are solutions. So what we want to do here is show the graph and write the interval notation for the solution. And I'm going to write set builder also. And set builder. Okay? I'm assuming you're still writing those two sentences up there. Parentheses indicate endpoints that are not solutions. Square brackets indicate endpoints that are solutions. Okay, here's how this works. Problem A. That says x is less than 3. Draw a little number line. Our critical point is 3. And less than 3 is to the left. So less than 3, here it is. There's my arrow. And is the 3 included? Well, that symbol does not have or equal to underneath it, so no, it is not included. So parentheses indicate where that is not a solution. You're going to, this looks weird, I know, it looks different than you've ever done it before. Let me move the, all right. That's what it looks like. Okay, a little parentheses and then your graph. The next one. B, x is greater than or equal to -1. X is greater than or equal to -1. Well, my critical point is -1. Greater than is going to be to which side? The right-hand side. So I will graph or shade the right-hand side. And let me ask you to not do something. I get students that do this. They graph the stuff over above the line. Please graph it on the line. It is the points on the line. So just bold or color or highlight or however you're shading it Do it on your number line, please, not floating up there in the air. Okay, now I need to deal with what about my endpoint? Is it included or not included? Well, that symbol says it's equal to -1. This says a square bracket shows how an endpoint is a solution. So here's my square bracket. There it is. It could have been even on the top and the bottom, but hopefully you get the idea. You'll see another one in a minute. There is a square bracket. And that's what you draw at that endpoint. Okay? And then the third one, C. -1 is less than x is less than or equal to 3. Okay, here is a solution set that's between two different points. So that means I have two critical points. -1 to the left, 3 is to the right. Now, the points are between. So I'm going to graph all the points in between these two places. But then my question is, what about the endpoint? Well, over here at -1, it's not included, so I'm going to put a parentheses. And on the right-hand side, it says or equal to, so I'm going to put a square bracket. That might look totally different than what you're used to, but that's a new notation that you need to understand, and that is part of our interval notation. Now, what I haven't done is shown interval notation. Let's go back to the first one. Hopefully you've caught up down there. Finish drawing that. Interval notation for the part A looks like this. We're stating the solution. It's essentially from where to where. Well, the leftmost part of this is the arrow which says -infinity. Everybody remember the symbol for infinity? It's from -infinity moving to the right all the way to what point? Well, there's this critical point on my graph, 3, all the way to 3. But around this, I need either parentheses or brackets or a mixture of them. On the left-hand side, that's infinity. Infinity always gets a parentheses. On the right-hand side, that 3, look at the figure. Look at the graph in the red up there is a parentheses. That tells me that's a parentheses. Okay? That 3 is not included. This is interval notation. It's a new kind of notation. I don't know if you've seen it before in Algebra 2 or not, but there it is. Let's do the one in the middle. Okay, the leftmost point, you always name interval from left to right. So the leftmost value is -1, starts at -1 and goes to what? All the way to the right is an arrow. Well, that means it keeps going and going. That would be infinity, so put your infinity symbol. And again, infinity always gets a parentheses. But the -1, there it is, the bracket is in the picture, so I put a square bracket around the -1. So this essentially tells me it's from -1 to infinity, including the point -1. In our third example, it goes from one number to another number. It starts at -1, comma, and it goes to 3. Now the question is, are any of them included? Well, the -1 is not included, so I put a parentheses there. The 3 is included, that side gets a bracket. So you need to begin to understand this notation as showing you an interval, which means a group of points from one place to another place. Now, set builder. Set builder notation kind of goes back to the equation. You're going to have set brace, and in this case my variable was x. So set builder notation for the answer to A would be the set of all x such that, now you could put a colon and sometimes it's a big tall bar. It means the same. I'll write the bar in the next one. Set of all x such that, and you get to write that equation. X is less than 3. Close the braces. There it is. That's set builder. Okay? So the neat thing about this is it takes that equation and it is your notation there, except you got to build it as a set. So in the middle, the set brace, the set of all x, and I'm going to use the bar this time, such that, because see, you might see it in one place with a colon and another place with a bar. So I need you to understand it, okay? The set of all x such that, and then I'm going to write that equation. X is greater than or equal to 1. There you go. Close the brace. And the last one, set of all x such that, and I'll write that equation. -1 is less than, x is less than or equal to 3. So set builder's actually easier when you're looking at the equation, and the interval notation is easier when you're looking at the graph. You do need to know how to do both. So we'll do both along the way here or there, okay? All right, let's move on. Solving linear inequalities. There's no title up there, but that's what we're doing here. Solving linear inequalities. 4x plus 5 is less than or equal to 9x minus 10. You're solving just like you solve equations. Remember, the only catch for solving inequalities is when you divide or multiply through by a negative, your symbol flips the direction. So less than turns to greater and vice versa. In this case, I would want to start by subtracting 4x. So I have 5x minus 10. And then 5 is less than or equal to 5x minus 10. Now we will add 10. 15 is less than or equal to 5x. And divide by 5. 3 is less than or equal to x. And now may I ask you, please, always turn your inequality so that x is whatever. So x would be greater than or equal to 3. You should be able very easily to flip that around. You've done these enough. Okay? We could graph that one. I'm going to save graphing. We'll move on to another problem that's a little more difficult, and we'll graph some others that are difficult. Compound inequality. Compound, we had compound fractions the other day. Compound in mathematics means that it's something and then there's some more of it. There's just a bunch of it piled on top of it, okay? So here we have inequalities with some more inequalities. So 3 is less than 4x minus 3 is less than 19. You see two inequality symbols. It essentially is the combination of two separate inequality statements. Because those signs are going in the same direction and the part in the middle is the same, we can solve this as if it has three sides, three parts, instead of a left and a right like normal equations. So whatever I do to one of them, I have to do to all three. So some of you may not have ever solved one like this. Hopefully you got it written down by now, and let's look for x. X is in the middle. To solve for x, the first thing I need to do is add 3. Now, I'm going to treat you like it's algebra 1 or 2 maybe. Add 3, add 3, add 3. Here, that's the whole idea. You have to do whatever it is to all three parts. So this turns out to be 6 is less than 4x is less than 22. Now, looking in the middle, there's my x. I need to divide by 4. So I'm going to divide the middle by 4, the left by 4, and the right by 4. And at this point, I'm just going to reduce. So 6/4 would be 3/2 is less than x is less than, that would be 11/2. And if you don't really like the fractions, you could say 1.5 is less than x is less than 5.5. Okay, or 0.5, however you want to write it. Any questions there? Ask somebody in the room. The idea here, there's 3 parts, and you do whatever you do to all 3. The other thing is the two signs have to go in the same direction. You can never solve it if the signs are pointing away from each other or pointing at each other. You need to know that. That would be wrong totally. You're doing the wrong thing. The two signs must be pointing in the same direction. All right. Now, solving an absolute value inequality. This is the big topic. Solving an absolute value inequality. I don't want you to write everything on here, so let's read a little bit and then I'll tell you what to write. If x is an algebraic expression and c is a positive number, okay, x is just an expression like 3x plus 2. That's what they're saying. X is your algebraic expression. C is just a number. And it says it's a positive number. That's important because we got absolute values and we don't want it to say an absolute value is equal to a negative or something. So be careful on that. All right, number 1, and this will be what you start writing, but let's read it first. The solutions of the absolute value of x is less than c are the numbers that satisfy this equation. The opposite of c is less than x is less than c. That's going to give us the clue or how to set up our equation. That means if this is a less than is between c and the opposite of c. Okay, copy that sentence. At the bottom of this page, you see a number line with c and negative c, or the opposite of c, which would be negative, okay, because c in the original up there we said was a positive. So the between, you see where between is, between c and negative c. It's in the middle. All right, so that's solutions that say less than. When the problem is a less than problem, it's a between. That's what I need you to remember. Number 2, the solution of the absolute value of x is greater than c are the numbers that satisfy these two things. X is less than negative c or x is greater than c. Now generally when I write it, I write the second one as the one on the left and the one on the right, and vice versa, okay? Because I start with the positive one and then I flip everything. You'll see it in a minute. So this is the greater than. When the equation they give you, absolute value is greater than something, then you're going to turn it into an extremes problem. That means the graph of your answer is going to look more like, go to the bottom of the page there, and the extremes are the arrows pointing to the right and the arrow pointing to the left, and it would be both of them because the answer is one side or the other side. Go ahead and finish writing number 2. And I don't think you need to write that other sentence. This next sentence says these rules are valid for, if it's valid for less than, it's valid for less than or equal. If it's valid for greater, it also is valid for greater than or equal. Okay, so the equal sign doesn't make the rules change or anything. All right, that just tells you whether you include the endpoint or not. So I need you to understand between and extremes. And maybe you don't yet. We're going to work some problems. Hopefully that should clear it up. Here we go. If you didn't get that, you can pause it and rewind it just a little bit and get what you needed. You can pause the video. All right, please just write down that first problem. Absolute value of x minus 4 is less than 3. Less than. This is a less than problem. What I remember, we just learned on the last page, is that a less than problem is a between problem. So I'm going to take what's in the absolute value, x minus 4. Notice I moved over a little bit because that expression is going to be between, see I put the two symbols, a less than on the left and a less than on the right. It's going to be between the number 3 and its opposite. But I do want to put it on the page right. See, that says less than 3, so the 3, this one comes over here, and the opposite of 3 is less than that. And how do you know you got it right? Well, if I cover up the middle, and my hand is over it, you can't see it, but my hand is over the middle. If you cover up the middle, it should be true without the middle in there. So negative 3 is less than 3. That's a true statement. So I know I got them in there right. So what did we just do? The original problem was a less than problem, and so less than is between. So I took what was in the absolute value, I put it in the middle, and it's between. So less than on either side, 3, and then a negative 3 on the left. I now have 3 parts. This is solving that compound inequality we looked at earlier. I got to do something 3 times. Solving for x minus 4, I need to add 4. So we add 4, add 4, add 4. You don't have to write those down, okay? You can do all that in your head, but here we go. Negative 3 plus 4 is 1. The minus 4 in the middle leaves just an x, and this is a 7. Okay, so my solution says x is between 1 and 7. We're going to graph this because you're going to need to be graphing some of your solutions. So let's do this one. My critical points are 1 and 7. And x is between. Now, remember that graph we had on the other page where we had c and negative c? I know 1 and 7 is not the opposite, but these are essentially opposites of that middle expression, x minus 4. Okay, so the less than is between. So I'm graphing everything between those two. The question is, do I graph the endpoints? Well, no. There's no equal sign there, so I put a parentheses here and a parentheses there. One thing about the parentheses, I know it can go left and right, same thing with the bracket. You're going to put it toward the points that are part of the solution. Okay, you wouldn't put it headed to the left if the points went to the right. All right, you want it to cup around the little values. All right, so there's my graph. What would interval notation look like? This interval notation looks weird. It's from 1 to 7, and neither one of those endpoints is included. It's a parentheses on the left and a parentheses on the right, and that's the one time when it looks like an ordered pair. Kind of makes me like, why did it have to look like that? It's not an ordered pair. It's interval notation. We're not doing ordered pairs, so you're going to understand it as interval notation. I'm sorry, it looks like something we know from previous knowledge. What would be my set builder notation? The set of all x such that, and I go back up and find the equation, or the inequality, sorry. 1 is less than x is less than 7, and there it is. Okay, so there's a graph, set builder, and interval notation. Please copy the example in the middle of the page. Absolute value of x minus 8 is greater than 3. Greater than 3. Okay, this is a greater than problem. Greater than is not between. Greater than is extremes. So I need to break this out of those absolute value bars into 2 equations. The first one starts as the x minus 8, bring it out, and bring that symbol down, greater than, and the 3. You just kind of just write it without the bars. Or it's x minus 8, flip the sign, less than, take the opposite of 3, negative 3. There's our 2 equations that we solve. So let's be careful, solve each one. On the left one, we're going to add 8, so x is greater than 11. Or, in this one, we'll add 8 again. X is less than, and negative 3 plus 8 is 5. So, let's graph. My 2 critical points are 11 and 5. Well, 5 is more to the left, so I'm going to put 5 here and then to the right an 11. I don't need all the little hash marks in there, okay? That distance is, at least I've got them in the right order. We're just looking for where the graph is. It says x is greater than 11. That will be to the right of 11. Is 11 included? No, so you have a parentheses. Or it's the other side, the other extreme, so less than 5. To the left of 5, okay? And is 5 included? No, 5 is not included. Now, we have not done an interval notation where we had two pieces on the line yet, so this is new information. Pay attention. Interval notation here. We're going to start on the left points and start talking about where we are. The left arrow there is negative infinity. All the way, the interval goes all the way to 5. Again, negative infinity always gets a parentheses, and we're looking up there, and 5 has a parentheses. So there's the exact statement of the left piece. And then it's union together with the other side. Starts at 11 and goes to infinity. Infinity gets a parentheses, and we look at the graph, and the 11 was not included, so there's a parentheses. There is the statement for interval notation for this particular graph. Okay? If I was doing set builder, I'm going back to what's written in green up there, the set of all x such that x is greater than 11 or x is less than 5. Close the brace. Okay? Those are pretty simple now. I probably won't do many more of those, but I did need you to see the difference in that interval notation there. Okay, now I'm going to grab this stuff and move it over a little bit. What happened to you? Sorry. That got all discombobulated. I'm sorry. Here we go. Please copy down this last one. Absolute value of 3x minus 2 is greater than or equal to negative 2. Please write that carefully on your paper. Now, this one says it's a greater than. This says the absolute value of something is greater than a negative 2. The number on the right's a negative. It says this absolute value is related somehow to a negative number. So let's think carefully. We had one in another lesson where it was no solution. But let's think through this. It says the absolute value of whatever's in that bracket there is greater than a negative number. Well, absolute values are always positive. So a positive is always going to be greater than a negative. This is the opposite extreme of the one we had earlier in a lesson where there was no solution. This is every solution. So all numbers will fit in there, give us an absolute value that's going to be greater than a negative number. I hope you see that. We don't need to work this one. We just need to think through it. And the answer to this is all real numbers. So there's the set builder notation for all real numbers, the R, set R. The interval notation for all real numbers is negative infinity to positive infinity with parentheses around each side. So the answer to that one is one of those tricky ones where they stick a negative in there with the absolute value, and you have to pause, think. Okay? All right, let's finish. Last idea. We want, what does that symbol in the middle mean? That symbol means intersection. Where do these two sets cross? Okay, that's what it's asking. So we have the set from 1 to 4. So on my number line here, it looks like I have 4 different critical points. I've got a 2 and an 8 along with the 1 and the 4. So let's get them all on here, and we can kind of do them so that the units look believable. Okay, there would be 4, and here would be 8, about down here. Okay, if we were to put all the little tick marks in, I think that would kind of give us 5, 6, 7. See, those are kind of equally, they're spaced right. Okay, now let's graph. I'm going to graph in green this first expression from 1 to 4. So from 1 to 4, starts at 1, ends at 4, and the two endpoints, the 1 and the 4, neither one of them is included. Okay? Now I'm going to graph the second set in another color, in red. So it goes from 2 to 8. So starting at 2, going all the way to 8. And this time it tells me the 2 is included and the 8 is also included. So I have a bracket on each of those. We graph the two sets individually. Now let's take a look at what they're asking us. They want the intersection. Where do these two things cross? What points do they have in common? Which places are graphed 2 times? That's all we're looking for. So we can see clearly between the 2 and the 4, everything there got graphed 2 times. I got 2 colors on the 2 to the 4. Now the question is, how about the 2? Was it included 2 times? Was it included in the green? Yep. Was it included in the red? Yes. So it got included twice. Did the 4 get included twice? Well, the 4 wasn't included in the green. It's a parentheses. So 4 wasn't then included twice. There's the solution to this problem. Okay? And we have a similar problem. I'm going to graph the same graph on there quickly because it should be there, but it's not. 2, 1, 4, 8. And from 1 to 4, parentheses. I'm changing to blue, sorry. And from 2 to 8 with brackets. All right, so this is the same number line. You don't have to draw it twice. You've got it already on your paper. Please write that statement, and the symbol in the middle doesn't say intersection now. It says union. Can I name the union of all of these points? In other words, can you name this interval that got graphed at least once? At least once. What got colored at least once? Well, we started down here at 1. We began at 1, and there's colored points included all the way down to 8. We colored the things continually all the way to 8. Was the 1 included ever? No, it's got a parenthesis, so 1 wasn't included ever. Was 8 included ever? Yeah, there's a bracket, so the 8 was included. There you go. Okay? So hopefully that gives you an idea of interval notation using graphing and using our set notation from earlier. All right? Here is your assignment. We'll leave it right there. You can pause it so it stays on the screen. And good luck. See you later.